This is AQA Combined Science Chemistry Higher Paper, June 2018, question 4. So we are dealing with halogens and we're dealing with bonding on this question. The question is about halogens. What is the state symbol for chlorine at room temperature? Well, hopefully you are recalling that chlorine is a gas and the state symbol that we use for that is a G. Figure 4 represents one molecule of fluorine. Fluorine exists as a diatomic element, as do the remainder of group 7. And you need to complete a dot cross diagram. Only show the electrons in the outer shells. That actually makes it a little bit more straightforward. Now there are 2 marks available here and I've colour coded them. One is for showing that there will be one covalent bond between the Fs. Fluorine is in group 7, so it has 7 electrons in its outer shell, so it needs to gain 1. So it puts 1 in for sharing and forms 1 bond. The second mark that you get here is for identifying that that leaves 6 uncombined electrons on each fluorine. And it takes us to a total of 8 around each fluorine, a full outer shell. Moving on to 4.3, a fluorine atom can be represented as 19,9F, where 19 is the mass number and 9 is the atomic number. What's the total number of electrons in a fluorine molecule, F2? Very easy to go wrong if you don't pay due attention to the question here. There are 9 electrons per atom. We know that because the atomic number is 9. That means there are 9 protons, and in an atom, the number of protons equals the number of electrons. But we're dealing with F2, so that means 2 times 9. Correct answer is 18. On to 4.4, aluminium reacts with bromine to produce aluminium bromide. Complete the balanced chemical equation for this reaction. Well, the first thing is you have got to know that the formula is AlBr3, or rather you need to be able to work it out. So let's take a look at how you might do that. I often go back to the seesaw method. I can put my positive ion under the left-hand side, my negative ion under the right-hand side. And then I put on my charges. Aluminium is in group 3, so it has a charge of +3. Bromine is in group 7, so it has a charge of -1. Now I need my seesaw to balance to 0, and I can only do that by adding more aluminiums on the left or more bromides on the right. I would need 3 -1s to counter the +3, and that's why we end up with AlBr3. After that, the second mark is available for the balancing, and because I've got 2 AlBr3, that means I would need to start with 2Al, and because I've got 2 AlBr3, that's in total 6 bromines, so I would need 3 Br2 to balance that. Finally, on 4.5, when chlorine reacts with potassium bromide, chlorine displaces bromine. Why is chlorine more reactive than bromine? Well, the first thing to consider is that chlorine is a smaller atom. It's got less electron shells. And that leads to 2 considerations, really. One is that the outer electrons would be closer to the nucleus, the outer shell is closer to the nucleus, and there's also less shielding by the inner electrons. Now bear in mind that when chlorine reacts, it gains electrons, it takes them in to complete its outer shell. So the chlorine can gain an electron more easily into its outer shell for the reasons that have been outlined.